All right, off to a late start as usual, but better late than not at all, I say. We're going to do some more Odinmade Hero, this live stream series where I continue to learn from Casey Muratori on how to build a game kind of from scratch, but not really, because we're actually using a lot of stuff that's baked into the Odin programming language to write the game that he's building in C and C++ with Odin. And so I've kind of jumped ahead in today's day, and it looks like my chat is broken, so I got to refresh that. But if we come over here, I'm about 20 minutes in, because in these first 20 minutes of day 47, where we're going to be getting back into some vector stuff after adding kind of a very, very minimal first pass at an entity system in yesterday's code. In the first 20 minutes here, Casey takes another look at some of the movement code, or at least one part of it, before jumping into this other part that we started off implementing last week, which is the whole search and P movement, or collision detection strategy, which I think is what we had down here, which was left in an unfinished state. All right, that's what our panic down here is about. So if we switch on that code, it's going to break and let us know. But in the first 20 minutes here, Casey just kind of goes over the calculation of a unit vector of the player's acceleration, so that we don't have to use this funky constant anymore. That is it's like the square of 2 basically, but proportional to the unit vector length of 1, right? And so now we can just get rid of that, and this will work not just for that case where we're going diagonally in any direction, but also with the analog stick for the Xbox controller over here. And he just kind of goes over the math for that, and it's not super I mean, it is interesting and it is worth retaining, but I'm kind of short on time, and I just wanted to jump ahead into wrapping up that movement code, whatever that looks like in the end, because I want to get through this day, and inevitably I'll get stuck on tangents of some kind, or just something silly. I'll get stuck on something silly, and I wanted to kind of jump in here because there's going to be a bunch more whiteboarding regarding this new movement approach that I think we're going to go with, that he decides on, because I think we were trying to do the search and P strategy that he talks about, and then he kind of backtracks that, and I just want to make sure that I'm doing as much coding as possible, as much actual coding as possible, instead of just watching him talk, because, I mean, nobody really wants to sit here and watch me sit in silence as I listen to him. You can listen to him if you want, if you're so inclined, by following the series, but the point here is for me to write this stuff in Odin, right? So we're jumping ahead here, and it looks like there's just going to be a smattering of quite a bit of whiteboarding to go over this movement code stuff, and then we'll get into some code towards the end. And so maybe it'll actually be a shorter stream for once. When I say it, I think it's going to be a shorter stream, but it never tends to go that way for one reason or another. Either I get stuck on code, or I get stuck talking about whatever for some random amount of time. And I just realized that my editor is not full screen. There we go. All right, so let's jump in and learn some stuff from Casey yet again.
Want to make sure everyone kind of understood what was going on. And so then, hey, there he goes, and he's good. So now all we have to do is concentrate on this problem, right? Where we're not grinding along the wall because we don't allow movement when we detect a collision, right? And so what we want to do is allow movement when we detect collision now and clean that up. Okay. So what we need to do for that, I thought about this quite a bit, and I talked about on a previous stream, I was talking about whether we should do search and P or search and T, and I kind of talked about how to implement both methods. And the more I think about it, the less I want to do search and P. I was kind of like really on the fence, if you remember. I wasn't sure, and I thought about it over the weekend, and I was like, you know what, I don't think it's a good idea. And the reason I don't think it's a good idea is because I feel like it's going to introduce a lot of complexity into the code for us for not a lot of benefit. Because really in this game, we're not going to be grinding against walls a lot. It's not like a walking simulator kind of a game. And I feel like the benefit that we'd get from having search and P, which I like better for collision detection in some case sense, is just going to cost too much in terms of the code complexity. So I think since we really never actually bothered to implement it, I'm just going to say let's not bother, and let's go with the more traditional version, which I was going to show how to implement anyway. Let's just do that method, because I think that method makes more sense because it's cheaper is the thing. And I feel like the cheapness is going to be important for us. That's all. And I don't think we're going to get much benefit out of the other way. So basically, all we really needed to do was come up with a better way of actually detecting when we were hitting stuff. So all we were doing before is when we actually go in, somewhere, we say we're here, and over a time step we want to go here, but there's something in our way. All we were doing before is checking that ending location. We were checking that ending location to see whether we could stand there. And if we could, we just accepted the move. If we couldn't, we denied the move. That was it. And so we need to do something better than that. And in order to do something better than that, the first thing we have to do is figure out what we actually hit and where we hit it. So we need to do something where we're going to look at what we could collide with. And we have to go ahead and say, all right, when we collide with something, let's figure out where we collided. And when we figure out where we collided, we will put the player there, right? We will update his velocity vector, which is what we were doing before, to basically not have any of the component that was going into the thing that he collided against. And then we will try again to move him. Now, we will try a few times. We will basically do this in a loop that tries a few times to get him to where he should be. And if it fails to get him to where he should be, I shouldn't say where he should be. It'll try a few times to move him the total amount that it should have moved him, right? Because when we go here, we'll find the velocity vector still there's still a delta t, right? Because we moved to here, and we know that he would have gotten there if this was the entire time step. We know that we would have gotten to here in less than that. So there's some smaller thing here, delta t 2 or something, right? That's a smaller thing. And we want to then use the remainder, that delta t remainder, we want to still try to move him by that much. And so hopefully delta t, the amount that's remaining, goes down to 0, and we know that we've done a complete move. But if we find that we just can't resolve it because there's all these crazy walls in there and he's bouncing around or whatever, we will just cut our losses and say, after 4 iterations or something, we're just going to consider that good enough, and we'll stop. Because we don't want to have something where we're going to do an unbounded number of iterations. That's just a very bad idea for something that's performance-oriented. And again, this whole thing is very tiny. We're talking about something that happens over a 30th or a 60th of a second. So these are like microscopic movements that we're talking about here. So how many bounces we support is not particularly relevant in terms of what the player can actually experience.
So it sounds like, backtracking the search and P implementation and going towards the search and T implementation is what he decided. And honestly, that was long enough ago that I did not remember that was actually what happened. But at some point, I'd like to actually come back and understand the search and P thing, and just kind of doing so while keeping in mind what he's saying, right? That if you're going to have a game with a lot of different entities that are always changing position, and there are tons of different things you can collide in, instead of a bunch of static level objects that don't move unless the player comes into contact with them or don't, react to other stimuli in the environment in the game level or game map, game world, whatever you want to think of it as. And so just keeping that in mind, what kind of game you're trying to make will probably inform that sort of decision. Hey there, Devil. Rag said, I'm always lurking. I saw your dad now. Congrats. Thanks, Rags. Yeah, it's definitely been the most awesome thing. It's really impossible to even describe what it has done to me. I do think that for a long time, pretty much ever since I met Chelsea, my wife, I started trying really hard to be the best version of myself all the time. And, nobody's perfect, so I'm certainly not doing that successfully all of the time, but I definitely look at just the impact that having that attitude has had in my life in the years since I've met her. And it's pretty clear that that effect and my reaction to the effect that she had on me was, it's having outcomes, really positive outcomes in my life. And then even more so since having kids, it just solidifies that I need to be the best version of myself at all times, for their sake. So definitely, recommend it. It's, in the years since having kids, I see a lot of anti-child stuff, and I honestly just don't pay too much attention to it. I just know that it's out there and I'm aware of it, and probably more keenly aware of it since I had kids, because for whatever reason, things that are relevant to you, the algorithm of whatever thing it is you're on will just start showing you stuff. But I do think in general that those people seem to be in a very sad minority. Rag said, I work in childcare and I absolutely love working with children. Can't imagine how great having a little you by your side. Yeah, well, that's awesome, first of all. I've been playing around with this notion a lot because, I like my job to the extent that it pays the bills and allows me to provide for my family. But certainly part of what's motivating me to do this stream is a desire to do something that I think is more fulfilling. And I don't think that that necessarily means going and working at a game studio where they're going to grind me into dust by making me work 60 to 80 hour work weeks during crunch time, right? So that's not necessarily where I think I'm going with this, but I do think it would be fun to get a graphics related programming job. And so that's part of the incentivization. Is that a word? Incentivization for me doing the stream. But more than all of that, I think it would just be really cool to make games that my kids would enjoy playing, and also be able to use them as a sounding board for, game ideas and things like that, because the expression, I think, is from the mouths of babes. Like, they can just speak a truth and they're not even aware of how prescient that truth is when they say it at times. But I also think about, like, if that's not what I do, what else might I do? It might be going into teaching, but I don't know what that looks like, because public education just seems to have been on the decline ever since, I finished high school. I went to public high school. I went to public school all throughout my years. I had friends that went to private school at various times or were homeschooled at various times, but all wound up at a public high school at some point or another. And that's how I, met them, was through school. And I think about, just how rewarding that is to have a good positive outcome on the education of a young person, because it really does. Yeah. So there's a lot to unpack there, and I don't want to get too sidetracked off the point of the stream, but it's definitely a motivator for me. Not just my kids, but having a positive impact on any young people, because I think it gets harder and harder to distill good guidance from bad guidance, because the access to information that we have now in the 21st century is so easy, but it's a double-edged sword, because you can access more bad information than ever before, just as much as you can access good information, right? It's never been easier to consume really useful knowledge and learn a skill, or just learn something for the sake of learning it. But at the same time, you can, just as easily fill your head with tons of bad ideas and bad things, thanks to the internet too. So anyway, enough of that.
As long as it's like, 2 or 3, I think we should be fine. So what I need to do is figure out how to compute that, right? I need to figure out how to compute that, and we'll start by computing it for the simplest case that we possibly could. We'll start by computing it with point versus line, essentially, right? So what we want to do is say, all right, we need to, we're going to have some kind of line, right? And we're going to have some representation for our guy and some concept of the direction he's going. And we need to figure out when he hits that sort of, whatever that is, that line, that blocker. So we're going to start with that as the simplest case, and we'll kind of work up from there, because I think, I don't know how much time we got left. So we got about a half hour left. So that'll be quite a bit for us to actually go through in such a short amount of time, actually. So let's focus on doing that, and then we will go ahead and see when we get done with that. We'll probably maybe tomorrow talk about how to do some more complicated stuff. Okay. So if we're just doing that simple case, what we need to start thinking about is how to solve equations with these vectors, right? Because typically when you have something like this, if I have something like that where I've got some kind of a line segment, right, like so, and I have some kind of a vector that's going in that direction, I now need to figure out how to do solves, because in order to figure out when, if I was going along this line, when I go here, we're essentially talking about something that's going to be some function of time, right? As time progresses, I'm moving. And I want to know when this function of time that tells me like a location of the player, when it equals some particular criteria, right? I've got, some value that I want to satisfy here, and I need to know when that becomes equal to something, right? And so if I want to do that, we're starting to talk about actually solving some equations. And so the first question is, well, what is the equations? What is the first equation that what is the first part of the equation that we're going to use? How do we represent this part? How do we represent there's a player and he's at a location and he's moving, right? Well, the most simple thing to do here, right, is to say, well, I start at a place. We'll call that p0, right? And then I move along some vector that's like a distance, right? I move in a direction. So I know that I've got some, p0, which is this point here, and I know I've got some direction. We'll call that d, and I'm moving along it in some amount. So if you remember, we did that thing where we talked about the linear blend, right? And we said, oh, well, if you want to have a linear blend between 2 points, A and B, right, you can think of it as the delta between them, right, B minus A. You can think of that delta between them. You can think of starting at A and adding some percentage of that distance between them, right? And this was the standard linear blend function, and I said it comes up all the time, right? Remember I said everything we do is going to have this in it. Well, guess what? It's going to happen here too. I've got a place I'm going to, I've got a place I'm coming from, right? And I want to move between them. Classic linear blend, right? So I'm going to talk about this as if I have this vector. So we're going to say that I have that delta vector there, right? And like I said, I'm going to call that d. So I'm going to call this difference between t. And so I'm just talking about that p0, which is this. I'm talking about p0 plus t times d, right? That will tell me where my guy is at any time t, right? So if he starts from here, I can plug in any time I want, and he will move along that line and just keep going, right? Now, if I want to, I can do different things here. I can phrase this in a couple different ways. I can say that d is the full distance that he moves. So it's like b minus a, if in this case here, or like this is the p1 he's going to. So in this case, it would be p1 minus p0. I could say that. And what that would mean is that t is normalized. It means that t ranges from 0 to 1, right? And when he gets to 1, he's done moving for this. That's as far as he can go, right? I could, on the other hand, also take d and say that d has length 1. The length of d is 1, right? That would be normalizing the d vector. And then t would range from 0 to whatever the actual amount is that would get him along that vector to the location, right? It would be his motion amount. So we have different ways we could phrase this. We could have t range from 0 to some value, or we can have it range from 0 to 1. And it depends on what we want our properties to be of these vectors. Do we want this to be normalized? Do we care? Stuff like that. So just keeping in mind that this could actually be phrased a couple different ways. The p0 is kind of unambiguous. It's where we started at the beginning of time step, where the player is standing right now. The d is somewhat ambiguous in that we know it's pointing in the direction of motion, but in terms of the t and the length of d, they are kind of interchangeable. We can move between different schemes there depending on how we want it to work, right? Okay.
I think I'm keeping up with him so far, but I'll break up the monotony of the whiteboarding since there's some activity in chat. Have you considered working for a smaller indie company, one that focuses on the passion instead of the grind? I mean, it sounds nice, but like, where is that? What indie company is that? You know, I'm aware of some out there, you know, studios where maybe that work-life balance would be exactly what I need it to be. But then, you know, you have all the issues that come with working for an indie studio, right? And that sometimes the money can run out and then you're out of the job. And because I do have a family to provide for, it needs to be a stable income. That being said, you know, it's not like a foregone conclusion that working for like a big enterprise is going to be stable either, because as we've seen over the last year or two, there's been tons of layoffs. The company I work for has laid people off 2 years in a row. Maybe they'll lay off more people next year. So it's not, you know, I shouldn't expect that the corporate job is going to be super stable long term either. But I try to offset that by being just as effective at my role as I can be, so that, you know, I'm not the fat that's being trimmed, so to speak, when it's layoff season. But yeah, I mean, something like that would be cool if it were an option, but I don't assume that option is ever going to present itself to me, or I also don't assume that whatever it looks like, whatever the opportunity looks like, I don't assume what it's going to look like, I guess. Because if you're always just angling towards one idea of what one thing is going to look like what is the thing that you're going to do, then you close yourself off from other opportunities. The other wild card in all of this that I don't really talk a whole lot about on stream because the time isn't right yet, but I do have a startup that I've been working on for a long, long time, and it's not anything to do with games, but it is a product that's just been cooking for a long time that I spend time on when I can at this point, but time to spend on that gets harder and harder to come by. But at the same time, that product is at a different stage of its life cycle now, where it's less dependent on me just always, you know, doing stuff and iterating and trying to get you know, some new version in front of people to get them to look at it. So I don't know. And that's what why I said earlier, what I said about the notion of maybe getting into education, because I don't know what that looks like, because I don't know that necessarily means like, what does that mean? Does it mean I go and teach programming to kids at a public school? I don't know that that's necessarily what it looks like, or that that's even the best application of for me, or of what I should do. So I just don't know. I guess I would say that I consider all possibilities, and I keep my mind open and my heart open to like whatever is out there. You know, I try to connect with people as best I can. Again, that gets harder and harder because now I'm just so inundated by helping Chelsea take care of the kids that I have to be very particular about how I spend my time. And so when I started seriously considering the idea of starting up streaming again, I was like, how am I going to do this? I'm not just going to get on stream and then play, fool around on a video game for a couple of hours. Like, the last time I did something like that was when I was playing Elden Ring or something like that. A couple years ago, before our first was born. Is like, if I'm going to stream, it has to be something where I'm trying to very intentionally do something. And it became clear to me over time that thing should be focusing on, continuing to develop my skill set, continuing to learn. And what was I going to learn? Well, I've always wanted to learn games programming. And so it took me a long time to realize this is the thing that I should probably do on stream. And I didn't know what that would look like for a long time until I decided on the format that the stream has been using now for a while. But I still don't know what that'll turn into. It just seems like the thing that makes sense to me to do right now. But at some point, there are lots of ideas, other ideas I have to format things as things go forward. Because we're going to run out of days. We're going to run out of... And I also think I'm going to run out of utility in doing streams this way. So it really remains to be seen. But I'm open to all the possibilities. And I'm excited for whatever comes, whatever it looks like.
So let's start with the simplest possible case we could imagine, right? The simplest possible case would be if we just know that we have, like, say, a vertical wall, right? We just want to know when this guy hits a vertical wall that extends, let's say, infinitely for now. So this is just an infinite vertical wall. He cannot go past it, ever. He'll never get past that wall, whether it goes up, down, any other way. But what do we know about a vertical wall? We know a vertical wall has an x-coordinate of something and a y-coordinate of everything, right? Any y-coordinate that you want is on that wall, but it only has one x-coordinate, right? So this can be anything, but this would have to be a specific value. And that would basically be like our wall x, right, or something. So we'll call that wall x. So if we want to, we could now imagine how we would directly solve this equation to see when a guy walking in that direction, right, would hit this wall. We would say, we want to know when the x component of this, so ptx, which is p0x plus t dx. Remember, because this is a vector equation, and I can always look at its scalar parts by just looking at the particular x component of it. If I have this equation, all I need to do is say whenever that equals the wall x, right? So this right here is the equation I would solve to tell me when I would hit that in t. So if I want to actually solve it, right, I can just solve for t. I get t dx equals wx minus p0x, right? I subtract this over to this side, so that goes over here. And then I divide by dx to get rid of the dx, right? So get rid of that and put it under here. Divide by dx, okay? So this is the time at which I would hit that wall. Simple enough, right? Not particularly complicated. But there's a catch here. I now have a... Well, you know what? I should probably be slyer about that. Does anyone know what the catch is here? Maybe you guys already know. There's a catch here, and I haven't mentioned it yet. We'll kind of see if anyone... We'll give you a chance to think about it a little bit. But I want to point it out. I wish I had more tea. But I'm regretfully out of tea. All right, so the catch is right here. When you divide by dx, you may remember from your high school math classes, someone would always say, the teacher would always say, subject to dx not equal to 0, right? They would say, I'm going to write it in our form, not math form, right? Dx can't be 0. I guess the math form is more typically that way, right? And they say that because dx can't be 0 because dividing by 0 is undefined behavior in math. You don't know what it is. At least it's undefined behavior in some math. The math we're doing, it's undefined. And since that's the case, since you can't divide by 0, you know that your solution to this equation depends on dx having been set to some value that isn't 0. Now, you may have always wondered, I don't care about that. What is that for? It's just lame, stupid. I don't care. When you were in high school math class, it's just annoying, right? But it's not annoying when you actually get to start using math for real. You realize it's very important and it's interesting. What does that mean? Well, what it means is, think about this vector. This is the vector d. What are its components? It is d is dx dy, right? That's the components. We're talking about this, the x-coordinate of the vector. That's how far it is like this. So, if I have my vector here, here's my vector d. We're talking about dx is down here, and here's dy. Well, if dx was 0, that means that the vector is pointing in either up or down, straight up or down. It's not pointing to left or right at all, right? Or it's not pointing anywhere. It's just 0. But if that were true, if this is pointing straight up or straight down, well, guess what? It's parallel to this line. So there is no solution to when he will hit this line, when the person walking along that will hit it. There's no solution because he'll never hit it. He can walk as long as he wants. He can walk to the end of time, and he'll never hit that wall, right? So what was stupid in math class, rightfully so, is actually quite nice in game programming. It is information, and that information has real meaning. And that's one of the most satisfying things about math is when you actually start to use it, you realize that all the stupid crap actually means stuff, and you use it, right? So when we're going to implement this, we have to look and say, oh, okay, if the x coordinate is very close to 0, this is becoming an undefined equation. We just assume that he can't hit the wall at that point, right? And we don't have to check against this wall at all because he'll never hit it. So what's the rest of this mean? This t value that comes back, assuming that he can't hit the wall, so it's got some x component. Well, the t value is either going to be positive, which means he goes some direction and hits it, or it's going to be negative, which means that like he was actually walking in the opposite direction of the wall, and he would have hit it if he'd walked backwards some amount of time. So this solution actually gives us how far it would take him to reach the wall walking forwards or backwards, and it tells us which one of them it would have been, right? So that's kind of cool. But we can, when this comes back, we can go, oh, we're just going to say we only care about stuff that's t greater than or equal to 0, because we actually don't care about him walking backwards into the wall. We're only checking the forwards, right? So that would be a pretty simple thing for us to test and to see what happens when he walks into vertical or, of course, horizontal walls would be the same. We just change this to wx, the wx and the px and dx would all change to y, right? So we now have that sort of, oh, you know what? I'm gonna try it. You guys ready for this? I'm gonna try it. Just scrolling over. Check it out. Man, that's cool. All right. So this is the equation. The t equals wx minus p0x over dx, right? That's the equation that we would use to solve for an x wall. And similarly, if we want to solve for a y wall, right, we would say the same thing, but in y, right? So that's how we solve for vertical or horizontal walls. Now with that, we can actually go implement mostly our tile map collision. And maybe we should do that. Maybe that is what we'll do. And then tomorrow we'll talk about how to do more arbitrary stuff. So if you think about this, when you think about this, we go, okay, when we do these collision detections, right, excuse me, we would be colliding against infinite walls. So we have stuff in our game where we've got these walls that have like holes in them and stuff. That wouldn't work, right? Because if we started colliding against this wall here, where, you know, here's the walls, right? And the hero's trying to go through this door, he'd never be able to get through there because the wall is infinitely high, right? It goes up and down and covers everything because it's an infinitely long wall. It's just testing against one thing. But obviously, if we wanted to, we could fix that pretty easily, right? Because when we find out where this would actually be, like where do we find out what the actual collision time is, right? We could then say, well, use that t value, because we have this function here, right? Plug that t value back into the walking equation, find out where the guy is standing at that time, right? So do p0 plus, and let's call this like our solved for t or something, plus t solve, right, times d. This right here will give us the solved for time p. That will give us this, when he walks, that'll give us this location, when he hits the wall, right? When he hits the wall, we can check the y coordinate to see what its range is. And if that range is not in between the two locations that we know of the wall to be, right, we could just not do it. So for every for every tile block that's solid, we could basically check 4 different collisions, right? 1 for each side of the block, and just check the range of the collision to make sure it's actually in between there. If it's not, we don't count it as a collision. We just move on. And so that's a pretty easy way, right, that we could do this. So let's go ahead and implement that. Since this may be very new to a lot of people, I figure like we shouldn't really jump ahead at all, if that makes sense. So that makes sense. Hopefully that makes sense. And again, so this is the yeah. Well, there you go. I need to get my. So there you go. Okay. So moving along, let's just go ahead and implement this code. It's pretty trivial, right? So if we go ahead and implement this code, this was our old code up above here.
Oh, before jumping into implementing this new approach with search and T, one thing that did come up in the Q&A for the previous day was the idea of using rotate left, this rotate left intrinsic, to get the source color values into the proper place from you know, while loading in the bitmaps that we're writing out, you know, like the hero's head and his cape and all that, and that backdrop here that we have. So rather than using these shifts on the results from using the count trailing zeros intrinsic on each of the mask values that we get out of the bitmap header, using those, I don't really understand the minutia, and I should take the time to make sure I understand it, but he changes these to be the scan value, and then gets the shift for each color slot this way, you know, by subtracting according to, you know, where they are in the U32 value. And then down here, use the rotate left intrinsic, but that's not what I'm able to do in Odin. So I actually don't have this code enabled, and I have this to do in here to remind myself that if they add the rotate left intrinsic to, you know, the intrinsics package, that I can use that instead of this bits call that I have now, because this is actually using this is off of the bits package, sub package, whatever, sub module, off of Odin's core math package, and it does a shift to rotate left, right? It does this instead of using an intrinsic. So, you know, I don't think it really matters, but it might be just as slow or slower than just doing the two shifts the way we were doing them before. And it's really only when loading in the assets, and it's not like they're really big assets, and it's not like there's a lot of them. So I don't know how much it really matters for this code, but I wanted to have something in there to capture that work, to give myself something more to think about. So anyway, that was that.
That we were using pretty straightforwardly, and so now we're going to have to write some actual collision detection code here. And so what we need to do here, well, I guess I can keep some of that actually. This is actually relatively important. What we need to do is loop over all of the tiles that are around us, right? All of the tiles that we could be hitting, taking a look at them and seeing if they are solid. If we can't stand in them, then we need to go ahead and see whether or not we would hit them by walking into them, right? If that makes sense. Yeah. So first things first, we need to map into some common location, and so let's just assume that the player is like going to be at 0, 0, right? That seems pretty straightforward. So let's go ahead and say, well, actually, yes, we don't even have to do that. We can just go ahead and say, all right, we have our tile map difference. We're going to subtract the player position from the tile position. That gets us the relative position of the player, I guess, in that tile. That seems, yeah, I guess that seems fair enough. Yeah, that's totally fine. And then all we have to do in here is actually implement whatever the check is that we actually want to do. Okay. So
looks like all he did was just get rid of this. So the code was not really, we weren't really that far along in that search and P implementation, I guess. Or maybe he's going to change a bunch of stuff up here, but right now it looks like I can just get rid of this. And I don't think this was ever implemented, or if it was like stubbed basically. Yeah. So I'm just going to get rid of that, since it looks like we're not even going to ever implement it. And then if I need to kind of backtrack because I want to try out that search and P implementation at some point, then, you know, I can always go back to that day in the code and start working forward from there.
Let's set up this loop. I guess this we have not yet initialized. So the first thing we need to figure out is which tiles do we actually want to check, right? Like, what are the tiles that actually need to be checked? And so that's actually another discussion we kind of have to have. Well, there's a lot involved here. I got to explain a lot of stuff. We may not get through all this tonight. All right. So if you imagine what's happening here, collision detection is complicated. Why can't I? Oh, I'm just because I got some stuff selected. So many things I have to do prerequisite-wise. All right. So if you imagine that I have my tile map, then we have to ask the question, what are the things that I actually have to collide with? If like my guy is, say, here, and the time step would move him to here, right? Well, the answer is I need to check all of the tiles that he could have gone through. So I need to check like the tile that I'm standing on. I need to check the tile that he would end up in, and all the tiles in between.
I'm really looking forward to when Casey, I know I've said this a bunch of times probably already, but I'm really looking forward to when Casey switches over to the black, you know, the blackboard instead of the whiteboard, because, and this is something I don't think I've even really brought up on stream before, but I have terrible, terrible floaters, which is basically just, you know, the material that makes up my eyeball just kind of dissolving and then getting stuck basically in the path where my retina brings in the light to form the picture that my eyes are seeing. And this happened, I first noticed this probably in, what was that, either late 2020 or late 2021. And since then, you know, some people complain about like a couple of floaters that they have, and that sometimes they're really bad and sometimes, you know, they're not noticeable at all. For me, it's more like I have a swarm of them, and it's in each of my eyes too. And so actually the whole flashbang thing is really bad because I just see like the black splotches of floaters all over, you know, the white background. So I actually do try to use dark mode wherever I can. But then the other part of me is like, it really only matters for me when I'm writing code. It doesn't bother me too much, you know, if I'm watching a video, but when I like need to interact with the screen, like I do when I'm writing code, I need the background to be as I just need all of the colors on the screen to be as non-combative with my floaters as possible, and this is the only theme, this is the best theme, I should say, that I've found for dealing with that. But it's not as much of a problem if I'm just watching a video. It's still annoying, but it's not the end of the world. But I can't ever write code, and I still occasionally see some people out there, like at work or whatever, who are still using like a white theme for writing code. And whenever I see that, I just wonder, you know, why they punish themselves like this. But Devil says, I've got a pretty decent amount of those fuckers. Yeah, it's pretty damn bad for me, and it was not an issue at all until like basically overnight a few years ago. And I thought something was seriously wrong at the time. Like I thought I was going to lose my vision completely. But nope, these floaters just showed up one day, and they're really bad. And I don't know, you know, that you talk to eye doctors about this sort of thing, and they're just like, no, you're screwed. You can't do anything about it. I had read online that there are ways to get rid of them, and there are. But when I asked my eye doctors about it, they basically said that if you get the floaters removed, it essentially speeds up the pace at which you will develop cataracts. Like you basically become guaranteed to develop cataracts within the following 5 years. So, and you know, because I'm so young, relatively speaking, like if I was in my 70s and the floaters were so bad that I actually just couldn't see anyways. Well, if you're going to develop cataracts, you're going to develop cataracts. Let's just get those floaters out of there, and then if you're still hanging on when the cataracts show up, then maybe we can get those removed. But yeah, it's just one of those fun parts of getting older, basically. There's nothing you can do.
Right? And so if you think about what that means, it's basically just a min-max situation, right? It's the minimum tile y and the maximum tile y, and the minimum tile x and the maximum tile x of the two locations, where he is and where he's going. Because if he was going to go like that or something like this, we'd want to check this whole rectangle, right? Because we want to check all of these things for collision. Now, really, if we want it to be, that's a conservative check, right? A conservative check means it checks perhaps more than enough things, right? A conservative check is basically one that doesn't necessarily check the fewest number of things, but it definitely checks all the things it has to, right? We could do better in the cases where we had something like this by actually saying, well, okay, the line the player moved doesn't actually pass through these guys here, right? It only passes through this one, this one, this one, and this one. So we don't have to do the full rectangle, right? And that's definitely something to think about when we're actually implementing the engine for reals, because that could save time. But again, these aren't going to be there's really no way to pass through that many tiles unless you're moving extremely quickly. But yeah, just something to think about. So all we really need to do is a conservative check at this point, which will basically say, okay, as long as we get all the tiles we might check, we'll be fine. It doesn't matter if we check some ones that we actually shouldn't have checked, because that's just like some wasted time, and that's like stuff to worry about in the optimization phase of things. So we don't actually care about that for now. So what we want to do is basically say, okay, the two places, the place we're coming from, the place we're going to, we want to take the min and max tile values of those and to know which tiles to check. So the min tile x is just going to be the minimum. I don't know if we never actually did we actually ever do minimum and maximum macros? I don't know if we did. Handmade platform.h, did we do any of these? Handmade.h, did we do them? No, we didn't. So there was a C++ feature that someone was mentioning that actually, well, okay, we don't actually need to use that for this, but I was reminded of something just now that, yeah, that maybe would be good to do in the future. But anyway, so if we go in here, we can define a min and max. Basically, if we want to do a minimum or a maximum of two things, so I've got two values, whatever they are, it's pretty easy to do that check, right? We can just say, if A is less than B, then the thing you wanted was A, right? And if not, then the thing you wanted was B. Pretty simple, right? And the same is true for the maximum. If A was greater than B, right, then you'd want A, otherwise you want B. That's pretty much all I'm talking about here. Very, very straightforward. Really nothing to it. But what I would like to do now is say, okay, so I've got the old player P, and I've got the new player P. So let's take whatever his abs tile, whichever one of those is a greater, I'm sorry, is a smaller for that one, and greater absolute tile index. Oops. There we go.
Okay, so yeah, the bounds in which we're checking depend on the smallest of those two values, so I can make sense of that. Old player P dot x and new player P, and this is actually abs tile x, not plain old x. And actually, this was also min. Doesn't look like it's complaining about me using these min and max built in, so that's good. Is this actually already a U32? It is. So I can just, I don't need to do this cast. I was thinking we were gonna pull these values off of something that was non-U32 for some reason. Yeah, so that gives us that, and then we want one past the max. Oh, I need to change that to Y. But we want one past the max. Well, I don't know if he's still going to do that, actually. So I guess I'll wait a second here before I get too hasty.
And then what I have to do...
Oh, no, he's got it right here. He's going to have to add 1 to that, to whatever the max is here.
...is I have to add 1, because I want 1 past...
Yeah. So do the same for the max. Place the Y. Oh, that's not going to work. Whatever. And then we need to add 1 to both of these. And that looks correct.
Past the maximum tile. And again, the reason I'm doing that is to make sure that wrapping works properly, if that makes sense. So there we go, max tile. Let's get that Y in there. And then this one will be minimum. There we go. So basically, I just got to get that minimum tile, I got to get that maximum tile, and then I'm going to loop and add 1 to it, so I'm 1 past it. And then I loop over those tiles, making sure that I stop when I get to that maximum one, right? And again, I had to use not equals, not less than, because I want to support wrapping. And you can't support wrapping with a less than, because if I underflow here and the min tile was less, then that would be no good. All right, so.
Welcome, big return player. Is this live? Kind of. It's half live and half not. I am live here on stream, but Casey over here is not. He is enlightening us, educating us from the past, nearly 10 years in the past, on how to make a video game. And I'm just kind of streaming myself, going through the learning process and implementing what he's doing in C++, but I'm doing it in Odin. How good are you at coding? That's a great question. I have no idea. I think it depends on what your definition of good is. I'm competent enough that I, earn a living programming, but my day job doesn't have me doing only programming. Like, a lot of it is just, like, there's some architecture there, there's some people skills involved, and just general literacy required to be good at my job. It's not enough to just be good at programming, but I do consider that to be a pretty fundamental part of my role. But the lines are very blurred, right? Because what a lot of jobs require you to be good at aren't really specific to code. It's specific to, like, how much experience do you have with some tool where coding is relevant, but not like the whole thing. And the job experience really requires you to have had a lot of exposure to that tool or that domain. And the programming is just kind of, or the coding is kind of like a side aspect of it. Like, as long as you have some kind of literacy with code, you could, and you could use that tool, right? You don't have to be a very good coder to use that tool. So I don't know. It really depends on what you mean by good. You'd have to qualify that somehow. But then I could tell you, oh, I'm good at that particular aspect of coding, or I'm not good at that particular aspect.
What I need to do now is say, okay, we're only checking things in our tile Z, so that the tile Z is not really relevant at this point. We then are going to say, we're going to figure out where the best place is to leave the player, and that's going to be, again, since I'm checking against all of these, I need to check against multiple of these guys, right? I have an equation that'll tell me when I hit a wall like that, but what I haven't done is figured out, well, okay, if I have tons of walls, what would I do, right? And the answer is just, well, okay, if you've got tons of walls that you're checking against, and you're checking against like this wall and so on, right? Then that puts you in a situation where I've got here, and I'm doing this sort of thing, and I test, like, this wall first. And I say, oh, okay, he hit it here. And so that would be some t. That's like some t that I solved for. They'll call that t far, right? But there was actually, later on, I find...
Yeah. You don't have to be quiet. Thank you.
Still warm.
Oh, double chocolate, huh?
It's chocolate peanut butter, but I did put chocolate chips in it too.
Yeah. Well, I mean, the dough is chocolate, right?
Mm-hmm.
Yeah. Chocolate on chocolate with a hint of peanut butter. Thank you.
Love you.
Love you. Got some delicious fresh cookies straight out of the oven. What's your specialty? Well, my day job has me dealing with a lot of data related stuff, using Apache Spark and Apache Airflow. and then a smattering of other tools that are kind of in that realm. But like the role that I fill on my team is kind of like if there's anything programming related, regardless of the specific tool, I'll go and chase that down and be responsible for that. But yeah, so SQL too. I write a lot of SQL and Python. And then for my startup, I do a lot of back-end web development and, again, more architecture stuff. And then I do a decent amount of front-end work, but I would say that's the area of my skill set that is the weakest on like the web programming, server land domain, I guess. Have I heard of Ada Spark? That's like... is that like a Spark library? Is that like Spark bindings in Ada? Front end feels like a waste of time. Yeah, it's not my favorite. I do it because I must, but it's not. It's the front end web development is the kind of programming I enjoy doing the least, for sure. Which is weird to say because I'm not particularly thrilled about writing SQL either. It's not something that really gets my goat, if you know what I mean. Like it's not something that juices me and gets me excited to write programming, but I'd rather sit and think about how to optimize a SQL query than, dick around with CSS for 2 hours trying to figure out how to get something to look a certain way. But I do like presentation. I do like graphics. So that's kind of a different thing. And I think that's why I'm picking up this new interest in graphics lately. So Spark is for contracts driven development, like preconditions, postconditions, rights pointers. Okay. Yeah. So that's something different from what I was talking about then, because I was only aware of Scala or Scala bindings for Spark, right? And Python bindings, PySpark. Let's say I made a button in a custom UI library and I give it the name of the on-press event handler and I give the handler a nice name. Could that possibly be a bad idea? Let's say, I'm going to read this again. Let's say I made a button in a custom UI library and I give it the name of the on-pressed event handler. So you're saying that the button has a name, like this button component has the name of onPressed, and you give the handler. Let's say I bind event handler names to text names of UI components for all components forever. Let's say I bind event handler names to text names of UI components. Okay. Honestly, it's hard to give any sort of feedback on that question without like a more specific. Yeah, I see a button, add item to. I don't know why I would name a button after a functionality, I guess. Yeah, you're saying, so there's some UI button and its purpose is to add an item to list. And it calls that. Makes debugging easier. Yeah, I suppose so. But again, that's the area of programming that I enjoy the least. But at some point, I'm going to have to get more and more comfortable with just UI in general through, working on learning how to make a game, right? Which is the point of the stream. So I should really get back to that.
I test this wall, and there's another t, right? The t became equal to t near when I did this equation, right? And I need...
I guess I would say that I'm usually constrained. Well, first of all, I'm trying to get in and out of having to do the front end development as fast as possible. So I don't think too deeply about, problem solving on the front end. Certainly not as much as I should. But also I'm normally constrained by what things are already named that I'm using to build the thing. And so I just want to learn how to use that stuff and then, get in and out of there. But if what you're saying is like, what if I gave you a library that made it easier to do all that stuff? I would say that it's not something that I would rule out of using. But again, it depends on, I guess, what ecosystem that library is going to be made available to me in. Like, I don't know, we're all used to the conventions on the web that you see everywhere, like what a modal is or what a form is. Like those things, I see it and I instantly recognize it. But I would think you might actually run into some confusion over whether the thing that you're looking at is am I dealing with the component or am I dealing with, like, you know, the event handler that it maps to. So it might be a double-edged sword, I guess, is the conclusion I would arrive at after having a chance to think about that a little bit longer.
Some way of figuring out, well, which one did it actually stop at, right? Which one should I use when I loop through all these walls and find all these collision points? How do I know which one's the actual collision point I should use? Well, obviously, we want the closest one. So we just want whichever one gave us the least value of t, right? So really what we can do here is just say, okay, we've got a t that we're solving for, and there's some best t, which is really just the closest t, right? The t that was the lowest, right? If that makes sense. We could also call that t lowest or something, or t min, right? And then what we want to do is say, okay, the minimum value of t that we want to start with, I mean, we don't want to entertain anything further than that, is just whatever the value would be if we allowed the whole time step to go forwards, right? So basically, if I was going to do the full difference between the new player P and the old player P, that's what I would do, right? And so basically, that's just whatever the player delta is. That's this right here, right? And so that player delta is basically the vector that would move us between them. So if I take its length, right? If I take its squared length, maybe I'll leave t min as a squared. But well, I'm going to actually solve the actual t. So we could also make t be equal to 1 if that. You know what? Let's just say that t is equal to 1. Let's do it this way. So I made this decision based on this thing I was talking about back here, right? Remember how I said t and d are kind of fungible? They have to multiply together when they get to their maximum values. They have to multiply out to be wherever the guy would end up at the end of the time step. But what I realized just now, because I was saying, like, which one am I going to do? It's going to be better if I just make the length of d be equal to the total movement, right? So that's the total movement he should do. And then t will be equal to 1. And that way I can just straight up set it at the beginning, and I don't have to really do any other work. So that'll be fine. I can straight up set it to 1. That's the maximum it should ever be. So any collisions that you find had better be lower than that. Otherwise, there were a collision that would have happened after the time step would already be finished, somewhere out here, like, you know, after he would walk much further or something like that. So, okay. So assuming that that is set up properly now I just have to go through, and if the tile is not empty, I have to test all of the walls and see if they need to update my team in, right? And I really don't need this best player P anymore, because afterwards I can reconstruct where I should be by looking at the team in.
I think you got rid of this best distance squared, right? Yeah, and did he actually get rid of the best player point as well? Seems like it. So we don't need those. And then, yeah, I still need to think about this. I don't think there's really anything else I can do, though, because this is not an option that's available to me for this for loop syntax. Yeah, I'm trying to think about how you would write this so that you would deal with the wrapping problem that he's talking about. Because this, basically the point is that this could wrap all the way around to 1, essentially, over the course of this iteration, right? Because we're adding to the U32. As we walk the distance between the min tile Y and 1 pass max. So I don't... Yeah, because less than wouldn't work, because you might start out... If you're going to wrap, then you're going to start out being less than. Yeah, I never did make time to look into that. There's not enough time in the world for all of these things that you can think about. You gotta pick and choose your battles.
Right? So that's pretty easy. So all I need to do here is say, all right, I need to solve my team in. So what I'm going to do is I'm going to test each of the walls of the guy. So I need to do like a test wall, if that makes sense. And so I've got the relative position of the player. I'll put that in a rel vector here. So rel new player p. I don't remember what we called this. We said we were going to change it to a 3D vector once we had them, but we didn't quite yet. dxy. Oh, I actually can just use that directly. There we go. So I could even do, yeah, well, never mind. Anyway, so I've got my relative movement here. That is going to multiply by t, obviously, to give us the motion that we want. So t min times this relative vector would move me from the player's current position to wherever. Oh, sorry, no, that's not correct at all. What am I talking about? That's his position relative to the tile. My bad. It's the player delta is the thing I was thinking of there. Player delta is the function, is the vector that's going to move us from our current location times t to be wherever the point is that we would end up, right? So what we need to do now is we need to actually compute this equation that I said we were going to compute for each wall. And so we've got it here, right? We said that it was ts equals wx minus p0x, the whole thing, right, over dx, right? And again, dx is just that player delta, right? So that's that player delta x. And then the p0x, that was where we started from. And so we know what that is. That's rel new player p, right? That's where the player is relative to the tile. That's his starting location. We're doing all this relative to where the tile is. And then we've got that wall x, which is the actual point that we want to test, right? So we've got the wall x there. So what we want to do here is we want to make this into something that we can call, and this is again going to be the t result value. We want to make this into something that we can call 4 times with 4 different values. So we can do test wall with like the rel player x and one of the wall x's, right? So like the minimum corner of the tile's x value, for example. We want to say that, and then we can say what its bounds are in y. So it's min corner y and max corner y. So basically, this is the location of the wall. These are the bounds where the wall is, and then we've got our value that we're actually. Oh no, that's sad. The stream is over. We're so close too. Well, I guess test wall will have to wait till tomorrow. What are you gonna do? All I was going to say is, all right, so the test wall function, right, it takes the wall information, and then, it takes the player, the rel new player, whatever, yeah.
All the wind taken out of his sails by the stream is over billboard there. So yeah, kind of a really just low-key day without too much coding, but I think I needed a day like that because I got another very upsetting email earlier today that made me have to go, and it just screws up my whole day. And I'd go into specifics, but it's not going to do anybody any good to hear me bitch about this. But the good news is I'm very close, hopefully I'm very close to not having to deal with any more upsetting emails for the foreseeable future, and I can go back to my regularly scheduled programming of just being as busy as I usually am.
I'm so deflated right now. Can you see how deflated I am? Well, some days go better than others. You can't always have the Q&A start at just the right time. And I have to admit, we were on a streak. I think we had 2 days. We had one day, yesterday, and then one day, I think maybe it was Thursday, where the Q&A started like exactly when I was done. So, what are you going to do? I guess we'll finish it tomorrow. We're mostly there. We just have to figure out a way to phrase this so that we can test each wall. So we'll just say to do test all 4 walls and take the minimum z. So that's really all we need to do. So what are you going to do? All right. Okay, I will go to the Q&A, deflated as I am of not being able to finish the code. I always hate it when we get to a piece of code and I can't finish writing it. That's something that doesn't really happen much in real life, right? Because you just program a little longer. But when you've got a schedule to stick to, you don't get that opportunity. So we're still compiling because we're still using the other branch of the code, so we don't have to worry about that. The code that we post tonight will still compile just fine, but we just want to turn on our actual collision detection yet, which we'd like to do. And so tomorrow we'll go ahead and do that.
So let me backtrack a little bit here. So that min tile and one pass max tile stuff looks pretty good. Just making sure that nothing is jumping out at me. Like, oh, you just weren't paying attention when you wrote this and you just wrote in the completely wrong thing. But it's looking good to me. This T-min stuff is starting to feel familiar the more I look at it. And so yeah, not a whole lot of difference. This wall X does not exist yet. So maybe I'll just call that a U32 for now. Is that what it is? It is an F32. That looks good, and then I guess we'll stub the test wall proc here, because I can't just if zero out that code and not have an implemented proc. Odin won't let me do that, regrettably, so we'll just do that, and let me go back to the... And maybe actually I can do that in Odin, but I just don't know how. I mean, there's obviously commenting the code out, but I don't want to have to do that. And we're going to have to write this eventually anyways, so I don't know what the signature is ultimately going to look like. In fact, this is wrong, right? We want 4 parameters, it looks like. Suppose I could always try and implement it myself, but I don't think I will. Maybe we'll just sit back and enjoy the Q&A for a few minutes before I wrap up the stream. See if anything interesting gets asked or answered. So this is just going to be... I don't know what these ought to be named, but we'll just say it's A, B, C, D for now. And that's fine. So if I build and run this, oh, we're not using either of those either, apparently. Yeah, I see that right here. And tmin, we'll just assign those to nothing for now, and we should still be fine. I thought that there was going to be more going on today, but just a lot more whiteboarding. It's a lot of math to get through, and it's pretty dry. You know, obviously, for me anyway, it's a lot more fun to code. I know there are those math people out there that will just sit and do math all day, and more power to them. But like Casey was saying earlier in the stream, you know, seeing the application of it is what's really fun, and all the things you can do with it. So yeah, let's go ahead and see. Might even be able to actually finish the Q&A. But if it's too dry, I think I'll just wrap up the stream and we'll call it early. And we'll actually have had an early stream for once.
All right, so please post questions now with Q colon in front of them so I can see them. And please keep the questions and stuff we've done on today's stream as deflating as it was. And if you want to ask things that are, or anything from today's stream or previous streams, if you want to ask questions about stuff that's off topic, you can do that on the pre-stream. So come 15 minutes early tomorrow to the stream, and I'll be on answering questions that are off topic. But please try to keep the ones in the official Q&A here too. The actual stuff we coded today or on previous days. So deflating. Stopping programming in the middle of something is so unsatisfying. Yeah, that's all I can really say about that. Just very, very unsatisfying. Yeah.
So defeated. But it's funny because, you know, there have been plenty of days before this one where it felt like he went a little bit, you know, just 10 minutes over or whatever, and that was enough to get the thing done. But I had that problem too, where I become deflated if I don't do a thing in the block of time that I've allocated from my day to get it done, and then it bleeds into the next day. But you had all these grandiose ideas about how you're going to build something else the next day, and then something else the day after that. But nope, it took you 1 week to implement one feature that you thought would take 2 hours because you made a lot of bad assumptions about how complicated it would be to implement it. I keep thinking about this idea of the big return player mentioned, you know, of using a bunch of components that are named after the event that they're related to. And I feel like I can't think about it off the top of my head, but I'm sure there's plenty of instances where that doesn't map right, you know, because it's like, I guess you would only do it for the UI elements that you cared to actually have like a physical representation of in your UI. But, and again, for example, well, yeah, no, because like if I saw an on-pressed component, I would be like, what the hell is that? I expect to see a button. I think that's where my mind would take me. Ahead of schedule, yeah, I know. But I pre-watched a little bit of this day, and I think I needed an easier day. Yesterday was a lot of moving code around, but it was also dry because it was just a lot of moving code around and trying to kind of compartmentalize some of the stuff. But it was nice to add this, kind of very simple and stupid entity type and start thinking about entities again. I'm mostly excited for once we get into the more interesting graphics related code and eventually getting into the OpenGL stuff, which I could probably start messing with now. Like one of the other things that I've thought about doing is working through, and I probably will do this, is working through the Vulkan guide on stream. And I don't know exactly what that looks like yet. But I think it'll just involve me doing all this stuff from start to end in Odin. The questions that I need to answer for myself are exactly how I go about doing that, but I feel like I'm just going to have to do it to figure that out. Like, I was asking some of the other people that are in the Odin Discord for kind of input on whether to use this, Vulkan memory allocator library, which just kind of gets you up and running with allocating Vulkan resources, right? To start doing things in Vulkan. But I feel like I actually want to know how all of that is implemented. And I kind of want to implement it myself. So now I'm like, do I do something really absurd and just hand implement this stuff? And also, like, can I just add this library and then write, do I have to write Odin bindings for it? Like, I don't know what the path of least resistance is here. And so that's just some of the stuff that I'm thinking about. There's also, learn OpenGL. And if I wanted to jump into this now, I could. It might not even be a bad idea. But, we've already made such good progress with the handmade stuff that I feel like if I just stick to this path for now, when we get to the OpenGL stuff, it'll tee things up nicely for me to either go and take what we've done for the handmade stuff in OpenGL and then just port that for Vulkan eventually. Implement the renderer with OpenGL and then just do the same thing with Vulkan. And then I have two implementations using two different APIs, right? That will help build a much deeper understanding of what in the actual hell is going on with graphics programming. Because I'm just not there yet. I'm trying to work on building that intuition. And it just takes time and lots of exposure. But we'll get there. I just need to keep thinking about it. But that's kind of where I'm headed, I think, after we reach a sort of inflection point with the handmade stuff where I feel comfortable spinning off of that and just doing something different. I don't know. To be continued.
I missed when you changed from FP to FT. Why did you decide to switch? So basically, I can explain that in a little more detail here. So basically, the reason that I decided to go with FFT, and you remember I was kind of hemming and hawing about it on Friday. I couldn't decide which one I wanted to do and so on. And so here's the reasoning behind it. So FFP, right, or I should say, FFP is the word. I call it search in P versus search in T. Right? So search in P has some nice properties, right? Search in P is bounded in iterations, right? Whereas search in T is unbounded in iterations to produce the correct answer, right? Search in P allows sort of smoothly ignoring geometry bugs, whereas this gets stuck, right? Geometry bugs, right? So these are like pluses for search in P and minuses for this. But search in P has a pretty big negative that search in T has a positive, and there's really two positives, one of which I don't think we care about much, but one of which we really do. So search in P, one of the huge negatives is you have to be able to search in P, right? Whereas search in T doesn't have to do that. So you never need to form the search space, right? The P space. And what that means is, like, with search in P, right? If you imagine I've got some crazy collision geometry here. In order to search for the closest point to something, like here, which is what search in P is doing, it's got to be able to actually know how to look through the space and figure out what that closest point is. Search in T never does that. Search in T just tries to drive in a straight line, and if it hits something, it changes direction. That's it. So it never even knows really necessarily what the space looks like. And that can be much more efficient, right? So this is definitely the more efficient algorithm in the normal case, right? The other problem is this is handles like bounciness better, right? And this doesn't. And that's because with search in P, you don't really know how many times you would have collided with a wall to get where you are and stuff like that. So this is a little bit better if you want bouncy things. This is better usually if basically this is a plus up until the point where you want things to bounce a lot, and then this becomes a plus, right? And so really search in T with fixing this unbounded in iterations problem, so just full on saying we'll produce the wrong result by bounding it arbitrarily, just is going to be way more efficient than this is. And so I just kind of decided this is, you know, just not going to be a good algorithm for us to choose because we don't really care that much about this. And we just give up too much because we have to do all this extra work to produce the space. In the witness, we have to produce the space anyway for other reasons. And so that's why I chose to, well, I didn't even choose to do this. This actually just turned out to be the most efficient algorithm in the witness because of the way we were doing things. But this is going to be way more efficient for Handmade Hero, I think, because we never build these spaces. So hopefully that makes some sense.
Still really need to play the witness. So maybe that'll help me intuit better, you know, why these two different implementations are better for the respective, you know, game that you would be building. You know, the design informs the implementation here, and it's hard to build a sense for that. But again, I think sticking to the, you know, what he keeps on going on about is just having a bunch of different entities that you're colliding with. Like imagine a bunch of bullets flying through the air and other kinds of projectiles, different enemies and objects in the environment. You know, 40 million different drops on the floor from, like, you know, carving down a Minecraft tree or something like that. Although those don't really collide. They collide with the ground, I guess. But as a player, you don't collide with them. Although you do to pick them up. So, I don't know. Some of this is still just very abstract for me. And making it more concrete as time goes on is just going to give me a better sense for what on earth, when on earth to make use of either of these.
How does the game handle the state of the two separate players when they are on different floors? Well, the collision detector just works, right? Because it's using the tile Z of wherever the entity that is that it's colliding. So that's doesn't matter. It's really the rendering that we have to worry about because we don't know what we're going to do when people go off screen. What we may do is just say that only the main character determines where the screen is, and the secondary character can't leave the screen. We might just make that rule so that we don't have to have like split screen or something that's going to be weird.
That was a big problem for Halo Infinite, right? Well, I think it was a limitation of the engine, is what I think I remember reading. But they took like a year and a half after release to add some kind of co-op, which had always been in Halo games historically. So if I add this guy here and then he goes up here, you know, this guy down here is just chilling out, but he can't actually go up here because he's rendering on, as though they're on the same plane. And we just hit an assertion. What was that assertion? Line 370. Oh. Right. So I think this is just because the other guy went off of the map. This used to be a guard against indexing into the frame buffer memory beyond, you know, its length, beyond its bounds. But I removed that to add these asserts so I would know when I'm seeing that happen. And because otherwise it would just silently ignore it. It would stop drawing it, right? Which is probably really what I want to do in a case like that. This guy can't actually change the view there, but if he goes up here and then goes all the way off basically this min value is clamped so that it doesn't, so we can't go negative, but the min value is not clamped so that it can't go off of out of bounds. Only the max is clamped so that it can't go out of bounds right here. So maybe that's what you do, right? Have like a, if min x and y are greater than, then do the same thing and clamp those. And then it would just get to the loop, but there would be nothing to iterate over because the min x and y are never, yeah, no, that still failed. What happened there? Is it because, well, maybe it should be width and height minus 1. Yeah, because the max are not equal to, they're not inclusive. So this would have like one pass where it would draw basically at the end of the buffer here, right? So I think that'll work. That guy goes up here. This guy spawns in. Nope, still failed. So I don't know, maybe I need to think a little bit more about that, because I would have thought, oh, well, because it adds, yeah. This offset simply cannot be greater than. So maybe clamping those is not the right way to think about it. And that makes sense, because even if these are at the max values, they can be, once we go to add this, that's actually going to go off. Yeah, it's going to go out of bounds. So you'd want to, instead of doing this assertion, you would just clamp that value right here. Like so, right? Say if the destination offset is greater than this length, then you would say the destination offset is actually its length minus 1. Because this loop actually won't iterate. Well, maybe it would. I don't know. This is still probably the wrong way to think about this. Because, well, max y... Yeah, no, this, it actually wouldn't... Yeah. It wouldn't, because min y would be greater than max y, and min x would be greater than max x. So actually, that's fine. So we would just calculate this and then not use it. We'd throw it away after indexing into the both the frame buffer, at least that's what I'm calling it, and the bitmaps pixel buffer. The same thing here. Source offset equals the length of the bitmap pixels minus 1. And I just like that better than wrapping this whole thing in a guard. I think that should be a greater than. Should it be greater than or equal to? Or should it just be greater than? I think it should be greater than or equal to. If this doesn't work, I should just give up, because clearly I'm not able to think about this right. So that looks like it works. If I navigate the second guy just way off, the input is still happening and his position is still being set way off screen, but we aren't triggering that assertion because that assertion isn't there. You know, we're just setting, but the real issue, right, and why I don't think I need the assert, but I do need something to clamp the offset into the buffers, is because it will trigger that that bounce check. And then down here, I guess I'm wondering if I should be declaring the source row here. I think that makes sense, because otherwise you'd be instantiating it every single loop, or declaring it every single loop from that outer loop from out here, and then you'd be just indexing into it after you've declared it. I think this is fine. I think I'm happy leaving this way. I guess I could break this up so it doesn't look so bunched together. And that's fine. Yeah.
Why is the code complexity for psearch so much greater than tsearch? So the reason is because of that process of searching. So basically, I've already told you, 25% or 50% of the code necessary. Like, this is not that far from the complete code that we're actually going to need to implement search in T. It's just doing this a bunch of times, right? And we're basically, all we're going to do when we move to a better collision detection than what we're doing, than just point versus infinite wall, when we move to like circle or ellipse versus sort of arbitrary shape or something, right? All we're going to do is have a fancier set of equations here, like a slightly fancier set, right? That's all that's going to happen. But the algorithm is the same. It's still just like, okay, drive along the line, see when you hit something, change the direction you're driving, drive some more, see if you hit something. That's it. That's all that happens. It's nothing else going on. And so given that that's the case, it's just really simple code complexity-wise to implement this. It's just the simplest darn thing. And if you want to do search in P, it's much harder. Search in P is basically a closest point problem. It says, take all the geometry that you've got, whatever it is that the person's walking through, take a point, and I want to know the closest point where to that point. And so what you have to do is you then have to know how to be able to search. Firstly, you have to do two things. You have to be able to search all along the edge of all the geometry to see what the closest point actually would be, which is very complicated. And you have to do that for another shape, right? Because whatever the shape the player is, it's not just really closest point, it's closest extruded point. So it's like, it's the closest center of some collision shape, right? So in the case of a player who's represented by an ellipse or something, it's the closest place an ellipse could be that's close to that point or something, right? And so you have to like Minkowski your geometry or do other kinds of stuff there. It's complicated. Whereas we will just be able to bake that right into these when we do them. You'll see. So that's complicated, but what's also complicated is the fact you have to know whether the player could have gotten there. So you still have to end up doing a pathing thing to see whether the player could get there, because you don't want them to be able to tunnel through walls with this system, right? And so depending on what you actually have, this is either very expensive or free. In the case of the Witness, it was free to do this, but in the case of this game, it would be very expensive, and this is going to be much cheaper. Why not treat the map as a matrix and validate objects and its collisions through coordinates? What problems can appear with this mindset? I'm not really sure what you mean by that. If the map itself was a matrix, that's really no different than what we have now, which is just a tile map. And the problem is that when you look to see, you need to know between 2 points. You need to know if you hit anything in between. And so you still have to write this collision code for the matrix thing. But really, remember, we're going to be doing something better than a tile map. So we're just using the tile map right now because that's all we actually have as a world representation. But we're actually going to be allowing all kinds of crazy stuff for collision detection. Like, we're going to be allowing arbitrary geometries for collision detection. So a matrix really wouldn't be able to store the world anyway. So your tiles are the 17 by 10 blocks. I'm fuzzy on collision detection as the player moves from tile to tile. I get lost on the world coordinate, tiles coordinate, and screen coordinate still, I guess. Well, I mean, we've kind of gone over this a bunch of times, so I'm not sure how to elaborate on it in any way other than how we already have. Basically, our tiles, you could just think of the tiles as a giant 4 billion by 4 billion array, right? So we've got abs tile X and abs tile Y for a person's location, and abs tile Z. Just think of these as a giant 4 billion by 4 billion by 4 billion world, okay? So it's a giant cube made up of tiny cubes that's 4 billion by 4 billion by 4 billion, right? Let's go over here. Okay, so this is our world, right? This is 4 billion long, this is 4 billion long, this is 4 billion long in tiles. So each tile is this tiny little thing, right? And then at any given time, we take out a little slice of that world, right? that's 17 by 10, or whatever we said it was, 17 by 9, something like that. 17 by 10, who knows? I can't remember what we're drawing, something like that. We take out a little slice from somewhere in there, and we draw it on the screen as the tile map, right? That's all we're doing. Now we have a sparse storage mechanism that breaks up this cube, since we can't store 4 billion by 4 billion by 4 billion, that basically just stores the places where there's actually world data in them. And so we have these tile chunks that are pieces that are just a storage thing, but you don't have to think about those when you think about collision detection, because collision detection doesn't care. It doesn't care where that data is coming from. It's just going to do the iteration of the absolute tile indices, right? And so for the collision detection, all that happens is we just pull out those tile values and go, okay, take where the player was and take where he's going. And let's check all of the tiles that that are around there to see if any of them are solid. And if they are, figure out where he would hit them and stop his motion there. And that's what we're trying to write right now.
I think I get it. I think this is probably a pretty good stopping point. I can finish up the Q&A on my own time and then come back tomorrow for, what's tomorrow? Line segment intersection collisions. Some big words in there. How much more whiteboarding is going to be in tomorrow's session? Looks like starting out, not so much. Maybe a tiny bit in the middle somewhere, but oh yes, he's switching to the blackboard tomorrow. That's so fortunate. I was mentioning that earlier. Yeah, yesterday's day actually looks pretty short too, so maybe, just maybe, we'll get through 2 days in 1 day again, but probably not. I don't think I'll be that ambitious. I'll be happy with just one. I can't get greedy. Can't get greedy. Said who? Said based stream. Hey, if you aren't being sarcastic, thank you. I'm going to assume you're not being sarcastic and you think it's actually cool. It's definitely still weird. I've been saying this a lot lately, but it feels really weird to be doing the stream. But the more I do it, the more I just kind of enjoy the results it's having. It's getting me to rubber duck, to myself and to, the various people that drop in on the chat a bunch. And I think it's helping me retain the information better. It helps that I've consumed a lot of this already. But now I think it's sticking more because I'm thinking through it out loud. And there's just something about that process that helps a lot. I've been so stuck in kind of, just in my own bubble writing code for so long. And that's one thing, like I don't miss being in school and I don't miss, that constant pressure to be delivering, a new take-home project or preparing for a final or any of these other things. But I do miss the collaboration that would happen with some of the my fellow students who were also trying to apply themselves really hard, and also with certain instructors that were very invested in helping you get the most out of the course and getting your money's worth. Not sarcastic. Odin is cool. Well, thank you, said who. Odin is pretty cool. That's the other thing that I just find more and more. Like yesterday, we moved a bunch of code around, right, in this move player proc. We moved this out and then got it working. We updated some of this stuff. We added this, notion of entities existing in our game state, right? However simplistic it was, but I would have expected that process of moving that code around to be much more painful, and Odin just made it super easy. And the more and more I mess with Odin, the happier I am. Like, yeah, we didn't have that rotate left intrinsic to get those color values slotted into the right spot, for the bitmaps that we're loading in. But if they add that at some point, then I can just drop that in. But there was still, there was some other functionality that I could just reach in and grab. And, also just writing the platform layer with SDL turned out to be pretty easy because, again, I can just import that vendored code. I don't know. Like, it's in many respects, it feels like the language, because I've always been interested in games programming. You know, it's something that's always been on my radar, something I might want to do as like a hobby or otherwise. You know, maybe if I was very fortunate, I could get a cool job doing something games related. But it doesn't, for me, it doesn't necessarily have to be games related. Like I've mentioned, like a graphics programming role would be pretty cool, depending on the, not even necessarily depending on the domain, but if there was like a need, whether it was whatever industry it's in, to have some kind of visualization software, and I was working for a company that needed to build that visualization software or simulation software, whatever, and I was contributing to that, whatever that company was doing, in the role of being a graphics programmer. I think that'd be pretty cool, but I'd done enough C++ and enough C to know that a lot of people have all these complaints about it, and there's all these, and to be fair, realistically, if I was to ever actually get a job doing something like that, it would be with C or C++, right? Like the notion that I'm going to go and get a job programming Odin full time is pretty lofty, at least in the near future. Maybe 10, 15 years from now, that's a reality, and there will be a lot of junior positions in Odin, and that'd be pretty cool, and I'm sure Ginger Bill would be stoked about it, and I would too, but we're not there yet. The industry is still fairly heavily entrenched, particularly in games, but any really kind of lower level coding is going to be using C, C++, Rust more and more nowadays, but I've tried Rust. I just didn't think I was smart enough really to come to grips with that language, and I'm sure I could have spent more time with it and eventually started to become pretty productive in it, but I've just always been more simple-minded, I guess, and Odin being very simple, it just works for me. It's allowed me to break more into this domain in a serious way, and I'm looking forward to continuing to continue this experience just because it's been so rewarding so far, and I think that part of that is owed to Odin. When I was doing it in Zig, it's not that it wasn't rewarding, but I kept on feeling in my gut, like, wow, the domain is fun, but doing this in Zig feels pretty painful at times. And I'd have times where it just really felt like I was fighting with the language. And that doesn't even mean that I wouldn't use Zig, in a more full-time capacity. It just means I feel like coming from that to Odin now, like there's just so many things that were a pain in Zig that Odin makes really straightforward. And I don't even say that to dog on Zig, because there's a couple of other aspects of Zig that were actually easier. Like for instance, I guess I could do like that foreign assembly call for this rotate. Where was that? Rotate left stuff. Like in Zig, I could just do something like inline assembly, and then whatever the syntax is to call that intrinsic. Can't remember it off the top of my head. But it's not like it's something that you need to do all that often, and like maybe it's something I'd never really need to do, because if I was making my own assets, they would probably not be BMPs, I imagine, but I really don't know. And that's a whole other topic. So Said who said, yeah, true, I personally just write C, and I like the language, but I've been following Odin. I wrote some program with it a while ago. Of course, since then it's been updated. Even in C, you could, but it's not standard. One thing that sucks with C is it doesn't have standardized inline assembly. Yeah, like it's kind of a mess everywhere you look, and that's why it's been daunting for a long time, I think, to break into lower level programming for me. And then you hear all this hype around Rust for a few years. Like when I first, back when I was still in school and I was trying to figure out like what kind of program am I going to be? What are the domains of interest that I'm going to pursue? And just due to circumstances and the fact that I needed a job like right then and there, I just wound up doing web programming and more like kind of like cloud software engineering, I think might be a better descriptor of me than web programmer, because a lot of the stuff I wound up doing professionally wound up having to do with cloud managed stuff that, you know, just wraps something like Apache Spark or whatever. But when I was thinking about languages that I want to pick up in my spare time outside of all of that, I think Rust and Elixir and Go and a few others sounded exciting. I guess some part of me, just being a novice programmer, I wanted to do something different and unique. And I wound up just sinking my teeth into Elixir because it was similar enough to Ruby, but it was functional. And at that time I was thinking like functional all the things, and you know, I was becoming functional brained, I think. So I thought, this is great. Like, it's simple, easy to write like Ruby, but it's actually quite different, and it uses this really mature ecosystem in the Erlang virtual machine. And even though like Elixir itself was relatively young at the time, I could kind of see the potential, and I ran with it, and I've done some pretty cool stuff with Elixir. But Rust was also there, Go was there. And one thing that I saw about Rust was that it was, you know, this lower level language, but you actually didn't have to worry about memory allocation, because you could just use the borrow checker to, you know, make sure that you're not doing messed up stuff with the things that you're allocating in your program, yada yada. And I messed with it a little bit, but it just seemed so daunting. And I remember that probably swayed me away from getting into it, because if that's the language, if that's the answer to all these C++ problems, like, I just feel I feel horribly hopeless to break into that domain in a serious way. And I think that's just because there was a lot more resources afforded to me to do the web thing. But lo and behold, now Rust, a lot of people are trying to do web apps with Rust, right? And so anyway, again, I think I could probably give Rust a serious shot today and figure out how to be productive with it. But I think it might be similar to, like, if I feel like I'm fighting Zig to get things done, I imagine it would be that much worse once I got deep enough with Rust. And that is a common complaint that I hear, is just the second you need to make serious changes to your Rust abstraction that you've done with the, you know, these types that you've made in Rust, the second your understanding of the problem changes, you have to go and make a whole bunch of changes. But something about Odin, again, it doesn't have a lot of these things. It's just so simple. Yeah, I think I'll be writing it for a good long while yet to come, because it's making these areas of programming that felt inaccessible to me easier, because I don't have to spend as much time, you know, just figuring out how to add SDL to my project, right? I just installed the Odin programming language, and away I went, and I don't want to stop. So anyway, thanks for hanging out with me. Again, it's been a lower key stream, but we'll be back tomorrow to do more of Odinmade Hero, and just take it one day at a time. So have a good rest of your evening, and I'll see you then.